Okay, today we're going to take a look at a spider beam. This is a beam that leaves the whole center of the room open, or the whole center of the house open, or the entire house open. You can support it at the ends. You can have as many spokes as you want, or as few as you can get away with. You can draw a floor plan and have the angles between your spokes bigger or smaller angles, and hide the support columns inside of wall intersections or whatever. In our case, we have an atrium that's about 8 meters across, and we made a spider beam that's quite a bit larger, and halfway out on the spokes it sits on columns, and the part past the column is cantilevered, so it's trying, the weight of that is trying to pick up the center of the hub, so the actual bending on it is much less. The real trick, there's only 2 tricks to these things once you figure out how strong to make it. You have to have all these rebars pass each other in the middle. And the way that's done, at least the way we did it, is we have basically 5 full-length spokes go from one side through the middle to the other side. We colored them different colors just so we could keep track of what we were doing. There's a red one, a purple one, a green one, a black one, and a blue one. So on the bottom was the black one, and this is number 12 rebar. There's 4, 8, about I think it's around 14 bars to the beam, and then the stirrups are like 9 inches apart. But the second layer, you can tie the stirrups on one side, and then you shove the free ends through the first beam you put down, and then you put your stirrups on the second side. And every one is 1 rebar higher, because the bottom bars and the top bars are sitting on a previous beam. So if you have, like we have 5 of them and 1/2 inch bars, that means that we're 2.5 inches higher with the last one than the bottom of the first one. So if we have 1.5 inches of cover on our concrete, that's 1/2 bar diameters, top and bottom. That tells you what's left for your beam height, to how big to make the stirrups. Okay, let's back up a little bit on this. Oh, my mouse doesn't work. Well, this will work. Okay, this is actually showing a little bit more than what we wanted to get into right now. But we were looking at this in the center in here, and there is no yellow. We were looking at this purple with the other colors, and how they were, one sits above the other all the way across, and the beam goes clear to the end out here to the end cap on the forms. This is also showing the forms. Let's see if we can. Something's gone wrong with the mouse. It's not like I had this thing seriously rendered or anything. We had some experienced lumber that was a little more than 2 feet. So we made a top and a bottom with these 2 straight edges are the angle of the forms in the spoke. And then we wrapped 2 mil galvanized metal around this to give a real smooth curve. And you can tell on the slideshows and some of the walk around videos that all we did when we were done was put some skim coat on them. Didn't need anything else. Okay, we're looking at a form here, and also and you'll notice that the plywood for the form is 24 inches high. It's half a sheet. And you notice it's exactly the same height as this here. All of it's the same. but it's set down with a spacer here for a piece of 2x3 cocoa lumber. This was just a test gauge that we went by and when we screwed the stuff together. And what that does is that leaves you a ledge on the forms. After you pour the beams, the concrete goes between this vertical wall, that vertical wall, and around the galvanized metal. Took 84 bags of cement, 2 times that in sand and 3 times that in gravel. Did it in a day. Kind of afraid not to have done it in a day on this. I really don't want to not do a floor in a day, and I didn't want to not do this in a day. But anyway, you pour all the concrete in there, and then you have to put a floor to cap this thing off. And we didn't have any additional supports or anything, only cocoa lumber running across from one, like here, you see the red ones right there, would be a piece, half a meter would get that, and then they were just longer. And that let us lay phenolic board in this height difference between this 2 and 3 and the top of the form. So the 2 and 3 doesn't come, 2 and 3 stalk doesn't come all the way up. That leaves you room for your phenolic, 3/4 phenolic board to fill in these wedges. And then we just poured the roof. This is looking down on it, and I think this has also got the forms in it. Yeah. You can see where we poured the concrete around here, and these things butted up, and they had some 3-inch T25 screws, about 3 or 4 of them into this on both sides. That keep the walls plumb and keeps the joints from coming apart. Also, we have 4-inch plastic pipes. The ones you see out here, those came up not to the top of the concrete. They came up a half a meter. Being that you got a 24-inch thick beam and an 8-inch thick floor, that's 32 inches. But these outer 10, one for each intersection, that's to put can lights in from underneath. There's 96 lights in this house, and that's just one of them. And if we get over here, we should be able to find. You have some other pipes here. I don't see where. I know there's 3 of them. There's one right here. It should be on this drawing. Of course, this drawing might be an earlier drawing. Might have saved it so I couldn't lose it and then added to it. But what these are also 4-inch pipes. This one's a 3. This does something different, but it would be a 4. There'd be one here, and there's one over here. And all the wiring that goes to the can lights and out to ceiling lights and air intake by the seagull grills, there's lights out there, and there's lights on the roof, and there's lights in the rooms, the individual things that look like rooms. The upstairs is not rooms. The upstairs is a controlled flow path for air. It's a duct. It just ends up tall enough. We changed the height. We originally designed it to be 4.5 feet. But once we got a 2-foot beam drawn in, it looked odd. The walls looked too short. And the forms that we've been using, the bottom section was 8 feet tall. So we just poured them 8 feet tall. Didn't have to do any different form work, just had to pour them. So that's what we did. When we used them downstairs, there was a 2-foot section that bolts up to the top of it and offsets by 3.5 inches. And that's how we would pour the top beam and the wall on the same pour. So it's basically, you can think of it as one very deep beam running post to post, or you can think of it as a column between 2 other columns. But it's solid concrete, and rebar is in it just like it was poured as a beam. Anyway, these 4-inch pipes, they have conduit run to everything out here. It's not home run till after the manifold. And after the manifold, it runs out some spoke, and then down through the bottom of the spoke into an electric box in that not a room underneath. There's 10 of those sub panels. It also gives you, when we made it 8 feet tall, we could walk around in there to do wiring. We wouldn't be going around on our hands and knees. So that little bit of concrete was well worth it. And we kind of think it looks nice. And it made the lanais. We didn't have the lanais before. So it was a many wins situation. There's also up here 20 3/4 inch PVCs run straight through the whole thing, the floor and the beam and out the bottom. And they mount a whole house fan structure underneath it there. It hangs off the bottom of the beam. And so those were put in ahead of time so we could just run threaded rods. Just like 4-foot long threaded rods right through the house. 2 of them would hold the fan, but we got 20. Just for symmetry. I don't know what else. And then there's 3 3/4 inch pipes, 1 up through the top and 2 through the bottom near the center. And that's for the motor for the fan. We didn't know we were going to use a some kind of a planetary gearbox motor or what, so we put in pipe that would come down next to the wiring box no matter what we used for to drive the fan with. Turned out we just designed a axial flux dual rotor. It's a handmade motor. It can turn very slowly and it can turn up to thousands of RPM. It's controlled by Hall effect sensors. There's a YouTube channel called Electro Noob. He's got all kinds of stuff on there, free to download. All the wiring diagrams and explanations of how it works and how to hook up MOSFETs and basically how to build a controller for your motor. And we pretty much doing that with the axial flux dual rotor. We got some 122 RC40 sprockets off of eBay, and 2 7/16 quick dismountable hubs goes in them. So it'll be a 2 7 drive shaft, and the fan shaft is 3 7, but it's actually 3 1/4 down there at the bottom bearing. It just got some lands around it so it can't fall out of there if the bearings go bad. And there are 570 feet of 3/4 inch conduit in this spider beam setup. There's almost as many conduits as there are rebars. I don't know if there's anything else to talk about on this. We might just... This mouse needs a new gizmo. This is what one of the pie-shaped forms looks like. These are the little piece that goes across the wall forms from the spokes. The black lines are just showing that there's a panel. They're not a part. The red lines are the phenolic board. Like there's 2 4x8 sheets here, and the corner that's cut off of here went over there, and the corner that got cut off of here went over there. And then there's a sheet just chopped up willy-nilly to make these couple pieces. There's 3 pieces actually for that, and they have to end up where you can put the seams together over top of these cross pieces. So the cross pieces aren't necessarily exactly 2 feet by 2 2 feet on center. They're wherever it had to be for the to work out. So we just cut them an inch longer than the drawing, put the phenolic board, set it on top, marked where to whack it, and put it in the miter saw. So they all fit pretty good. All the screws had to be put in before we put the phenolic board on from underneath. Reason being, you have to get under there to take the forms back apart. And these forms, these side forms, 5 of those turned into the side pieces for our construction stairs. We had to replace the cocoa lumber stairs with, this is Nara. When you order hardwood, you don't know what you're going to get. Sometimes you get Nara, sometimes you get mahogany. But we're saving all of it because it doesn't rot. We're going to make furniture out of it in the end. It goes right back in the house. There'll be some holes to put dowels in where bolts were put in, big bolts were put in them. But that'll just give us some character. A big round window form, that's going to be a table. Small round window form is going to be a nightstand. The half rounds are nightstands in 2 bedrooms. It just needs a glass top and infinity lights inside of it, half mirrored. So that'll be fun. Let's see what else we got here. Well, that was a mistake. View, set view, top. You can spin any of these around in perspective, any porthole. This is something that's not real terribly obvious. Now, the one on the left just shows how those things fit onto a 2 4x8 sheets. Because these plastic pipes that are going to mount the fan, they're stuck in these phenolic boards, and then they go up through the top, and we just tied them off what seemed to be plumb. But we needed to know where they were in the bottom. So we saved these 2 pieces of phenolic board, and then we just flipped them over. You know, when you drill them, it splinters a little bit on the bottom side. So we knew which was the bottom, and we could tell from the holes, you know, which is left and which is right. Basically, if you know the top and the bottom, can't put it together wrong. But that let us build the that ring frame that bolts up here, and it'll be a perfect fit. Over here on the other side of this is a 2 4-foot sheets, and they were spaced up on something like looked like a ladder on either side. Just some experienced cocoa lumber to give it the right height, because there was a floor underneath all this that we were walking on building it, because we had decked the whole thing to pour the donut floor around the outside, and there's stands for the first floor, and they sit on a piece of 2x3 spacer block. So you pry them up and knock the blocks out, and the stands come right out to use them again, so you don't have to beat on them. Well, we just took some of those from that were made for the second floor, and we put them in the center up here and decked it. And this thing had to be spaced up so that it would be the same height as the top of these sheets here. Top edge of that has to be the same height as the top of the concrete on the floor, and then these things laid over top of it. There's like a center, a left, and a right. And here's a center, left, and a right. And here, this one and these ones are just angle cut. They haven't got the little hook thing on the end. But having that hook thing and being able to measure across these ends to a different number, you put one of these in, you poke the other one in, and you measure across the distance, and the middle one just goes halfway between. I'm not sure what those circles are. They're just circles. I don't clean up drawings near enough. This is just showing those pieces. Like these are the ones with a notch and one halfway between, and these are just bevel cut. They're showing what they look like. The skinny thing going on here is the actual spider beam. It doesn't go to the edge of the roof by about 6 or 8 inches, because there's electrical boxes and a light there, and it just keeps the rain off of it. I think this floor is 32 feet. Well, it's 395 inches. Is that 32 feet? I don't know. And the length of the spider beam, each beam, is 376.25 inches. Of course, you can make this any size you want, you know. This could be a beach house with the ends out here sitting on posts and the glass walls all the way around. And then this is just an architectural feature in the middle of the room with a big fan on it. It's the focal point of that round living room. Every room's got to have a focal point. The stairs room's got the helical stairs, the kitchen's got the counter. This room has got the fan and this spider beam. But there's a focal point in every room in the house. But we need not go into that right now. This scroll wheel is wore out. I was hoping I had something showing where the actual beams are, but I don't. Not in this drawing anyway. I had the dimensions of the beams. The beam would be here. It's outside of this. This is our clear line. So the beam is here. It's like 20 inches front to back and 32 inches side to side. It's two of the, actually it's all four of the forms that we did the outside posts with, inside post downstairs. They're put together differently. We took the two narrow ones and put the wide ones on either side of them hanging over and made a different shaped rectangle out of the same forms. So that let us use those a few more times. We're changing over to slip forms now due to watching a video by Texas Filipino. All my little stuff outside is going to be slip form. Oh, this is our first run through on ceramic tile. Manufacturer, the material, size in millimeters, model name. Some of them have model names and some of them are textured. Product code and price. And the reason we needed to know that is because we're going to cover this roof up here with ceramic tile, just like you would a kitchen floor. And also the ring roof with the atrium, or the lanais. Got 5 lanais around here. Every one of those has got every other one's got a lanai. So we're going to put ceramic tile up there. That way those hairline cracks you get when you pour concrete in the sun and high wind, and you can't keep it wet or won't keep it wet, they get these hairline cracks and water can get down through there. So we're just going to seal it off from the top with ceramic tile, and the bottom is already sealed off with SKIMCOAT. So that's the plan on that. There's nothing else of interest here. Okay, so we're going to stop this video, and then we're going to do one on how about the stages of slip form construction? How you would actually build a house with that, whatever height walls you wanted, poured in sections. You can pour pretty much back-to-back days. Like if you have your forms bolted up, you can take them off in the morning, slide them up, clean them, and throw some WD-40 or Pam Kitchen spray or something on them for release. Pick them up and put the bolts back in, and that afternoon you can pour it again. And then the next morning you can pour the, like if it's 3 lifts, you do the 3rd lift. And you would stop at a door frame, end of a wall. I got a video with dimensions that we're using on our slip forms, and it shows you how to make a 90-degree corner that all bolts together. If you take 2 of the inside corners and put them against the 8-foot long outside one, you got a T intersection for a wall. I didn't bother to put that on the video, but because I knew it could do that. And but the other thing is we wanted to make a nice 90-degree intersection, because the advantage to the slip forms is you haven't got to have posts or beams other than the tie beam under the ground for under your major floor, the grade level slab. You have tie beams down there to set all the weight on, but you don't need columns. The intersections are continuous around the corners and things. Just a wall with a bend in it. And it's poured concrete just like your column would be. And why would you put a beam on top of a poured concrete wall that's already got rebar all through it? Just take a spray can and put a line across there and write beam above it somewhere on the wall. Call that the beam. You don't really need a beam. Now, we did put ours together with stirrups and long bars. You can tell that the thing is overkill on bars. You're looking at the blue in here at pretty much the top and down one side, and there's bars across the bottom. Where these look twice as wide, that's actually looking 2 and 3 bars. So there's 14 to 16 rebars per beam, and our walls down there, the top rebar is poured wall. They're just like that with the stirrups. Everything we did has like it's a separate beam, but it's not. If we had got to a situation where we couldn't mix enough concrete in a day to do what we wanted to do, we could stop at the top of the wall, 2 inches below the beam, and then pour the rest of it tomorrow. Would have made no difference, because the rebar for the wall runs up through this another 2 feet out the top of the beam, and they get bent over into the floor. So when you're pouring these outer walls and you haven't put your floor up there yet, then you got these over 2 feet of beam sticking up, and there's a thing on our stirrup building and shows how many vertical bars there are in this house. But we saved 6 of them to put additional height on something if we needed it. And now that we've gone with the ornamental iron, we don't need it. But all the rest of them are bent over into the floor. And then while these beams were wet, we had some 2-foot long pieces of rebar. Actually, I believe we cut them for this. They're some are 16 if they were drops, just left over laying on the site, and the rest of them we just cut them out of 12s. They're stuck down in this wet concrete, and then after we pulled the forms off, we bent them over, and we bent the one on the extreme right to the left and one on the left to the right, where they cross over, and that ties these floor sections. You know that we poured this roof up here as the left side and the right side, half the roof one day and the other half about a week later, because we took all these forms down and moved them over there. Only had half enough fabricated. It would have been 140 some bags of cement if we'd done the thing all in one day. And we only had one mixer on the roof. The other mixer was on the ground. And was the thing that locks it from turning upside down. That thing gave out and near hurt somebody. So we marked that one, do not use. And I made a new parts and put them in the one upstairs. And then we took the ones off the downstairs and threw them in the trash. So the downstairs mixer, if we want to use it, we got to unbolt our catch handle and put it on it from the other one. I just haven't got to making those pieces. I got drawings in the computer. I know exactly how to make them. Haven't even got a measuring, just Xerox it and carry it to the machine shop. Anyway, let's do one on slip forms here in a minute, as soon as I figure a way to stop this from running.